In this video, we'll take a look at using velocity within a physics environment. For this example, we'll use a simple rocket to apply linear and angular velocity to have it fly through the air while rotating. Along the way, we'll also go over some tips and tricks on how to parent imposters and utilize velocity with a local axis. So let's get started. Okay, let's start off by looking at our starting scene. So in here we have a model of a rocket. I took this off Sketchfab. I will be providing a link to it in the description, but I'm also going to be providing this in the code repository. So this model is quite small. So you can take a look around in here. We can see that the environment is much bigger. That's perfectly fine. This is more of a cartoonish looking rocket. And what we're going to be doing in this video is we're going to be going over how to utilize velocities. So velocities will allow us to have this rocket fly up into the air. We're also going to be going over angular velocity so we can rotate this as it's flying. Okay, let's take a look at our code. So we're starting off with a class called physics velocity. This is a modified version of the physicsdemo.ts file that's found in the snippets folder. Again, you'll find a link to the code repository in the description. I'm calling a new method in here called create rocket. We're going to be using the same method for everything for the rocket. So importing the mesh, using the velocities, creating the imposters, whatever that may be, just for the rocket will have its own method. In the create scene, I did modify the lighting. So you may have noticed that we're using an environment texture. And I'm using the same kind of setup as before for creating the default skybox with an environment texture. Since we are using PBR materials with the rocket, we really want to make it pop. So we're using an environment texture for that. Okay, so everything else is exactly the same. This is importing the Tune rocket. So I do have that already available in the models folder. You can see it's right here. This will be available in the code repository as well. Now we are going to be using this as the visual aspect of the mesh, but I want this to be able to interact with any other physics elements in my scene. So what we're going to be doing is we're going to be creating a new imposter for the rocket, but this will be a separate object, and that object will then be the parent of the rocket. Let's take a look at how we can set this up. Okay, let's create a abstract mesh. This will be a basic box. We're going to call it rocketcol, so that's short for rocket collider. So new mesh builder.create box, and we're going to give it a name of, we can go with rocketcol as well. And then for the size, we are going to be modifying this. I have done this before, so I know exactly what I'm going to be using. So we're going to modify this to have a width, height, and depth of 1, 1.7, and 1. So width of 1, height of 1.7, and then a depth of 1. Okay, now these are the values that I found that closely resembles the overall shape of the rocket. Now, do note that the rocket does have a kind of a smooth surface. It's not like a box like the rocketcol, but with these dimensions here for the width, height, and depth, that closely matches the shape of the body of the rocket. So we're going to go with this. You can modify that to your own liking, but you'll see how that looks in a moment. Now, what I want to do is also modify the position of that box. So if I were to just save this as is, let's take a look at what we have so far. Let's make sure that we are calling create rocket. So we are calling it right here. So we should see the box at the center point of our world. Okay, so there is the box. Now it is going to appear black. I'm not too worried about that because we're not even going to be actually seeing this. We're not going to be rendering the actual mesh of the box. But as you can see here, it's actually kind of halfway into the ground. If I take a look from the bottom, you can see it's sticking out. Now remember, when we're creating an object like this inside of BabylonJS, the center point of that mesh is where the origin of that mesh is. And when you place it at the center point of the world, it's going to be using that origin to determine where it needs to be placed at the center point. So we need to move this up a bit so it actually covers the top of the rocket. Let's go back into our code and let's modify the Y position of this box. Okay, going back to our code, the height is set to 1.7. Typically, if you want to have this set up to be perfectly flush with the ground, you'll take whatever the height is and you divide that by 2. Now, dividing 1.7 by 2, I'm going to go with a value of 8. It's not exactly the same value, but it'll be enough for us to actually place this slightly above the ground so we don't actually notice that it's sticking through or above the ground. So I'm going to set the position here. I'm going to say rocketcol dot position dot y. I could also use a new vector3 for this, but I'm just modifying the y-axis of this, and I'm going to set that to 0.8. Let's take a quick look at this, make sure that this is set up properly. Okay, so this looks good for the most part. As you can see, it covers most of the rocket. I'm not really worried too much about the fins. I'm not really going for super accurate collisions with this. I just want to cover most of the body. And I'm mostly concerned with the main body of the rocket, not so much the legs or the fins here. All right, so I think I'm good with that. Let's continue with the rest of this. Okay, now like I mentioned before, I don't want to be able to actually see the collider itself. I want this to be invisible, but I still want to be able to use the physics elements of this. So for now, as we're playing around with this, and just to kind of get a good idea of where this collider is at, we can adjust the visibility. Before we use something called is visible, now we're going to be using the visibility to adjust the actual opacity of this mesh. So let's start off by writing out rocketcol dot visibility, and visibility is a number. And I'm going to set that equal to 0.25. Okay, this will make it slightly transparent so we can actually see the rocket inside of the mesh of the rocket COL. We'll take a look at that in a moment. Let's continue forward with this. So now what I want to do is create the physics imposter for the rocket COL. So we've done this before, rocket COL.physics imposter, and this will be a new physics imposter. And the object is not going to be a string, it's going to be an object. So rocket COL is the object. Next, we need the type. So the type is going to be physics imposter dot, and I'm going to use a box imposter that closely matches what we have for the shape of this mesh. Next, we have the options. Now I'm going to set the mass equal to a value of 1. That's really the only option that we need to add to this. We can also play around with the restitution and the friction if you want to. We can take a look at that in a moment. Let's just start off with a mass of 1 for now. Okay, so we have our physics imposter and we have the mesh itself, but we need to tie this together with the actual mesh of the rocket. So if I were to apply forces to the physics imposter, I want to make sure that it looks like the rocket is actually being affected by it and not just the physics imposter of the rocket COL. So the way that we would do this is by making the rocket COL the parent of the rocket. So remember, the meshes 0 is going to be the root object of all of this in here. So that's what we want to use as the child of the rocket COL. There are going to be a few ways of parenting. So let's go over a few of these just so you understand how they work and why you would use one over the other. So I'm going to start off by determining what I want to use as a child first. So meshes 0 dot, and there's a few ways of setting a parent for this. I can say dot parent, and take note of the description. It says gets or sets the parent of the node without keeping the current position in the scene. So let's just try this out. This takes in a node, which is going to be rocket COL. So the parent is going to be rocket COL. Okay, looking at our scene, we can see that the box and the rocket are not perfectly aligned. You can see that the rocket is near the top of the box. Now remember, the origin point of the box, the mesh that we created inside of Babylon, is near the center point, whereas the origin point of the rocket is near the bottom here. Now, we can't actually see the origin points, but they're basically being aligned in that way. If the origin point of the rocket was right here, we would actually see this better aligned. So there is a way to adjust this. Right now, instead of using the origin point of the mesh, I could just say, hey, don't move the orientation or the position of the rocket, just keep it where it's at, but still use the box as the parent. So we're going to be going over the second method of adding in the parent. So going back to our code, if you do want to reposition or reorientate the object as the child, you would use dot parent for that. But in my case, I want to keep the rocket where it's at. I just want to make sure that the rocket COL is the parent. So instead of doing it this way, we're going to use another one called set parent. So set parent will allow us to do this without actually modifying any of the position or rotation or anything of that sort of the child, which is meshes 0. We're going to pass in rocket COL. Okay, let's take a look at what this does. Okay, and there we go. We can see that the box and the rocket mesh are now aligned. Now, we didn't actually adjust the position of either of these. We just said, hey, let's go and parent these up together. And now they are connected. Now you will notice if I refresh this, that the box actually jumps up a bit. And the reason why it's doing that is because the box actually starts off below the ground. And with the physics engine, it's trying to basically disconnect or prevent the intersection of these two colliders. They shouldn't be intersecting with each other. So what we can do is actually have this start off just slightly above the ground a bit further. Right now we have it at 0.8, probably bring this up to maybe 0.85, maybe even 0.9. Okay, going back to our code, let's set the Y position for the rocket COL, maybe up to 0.85. That should be enough so it doesn't actually get stuck in the collider of the ground. Okay, so you can see it no longer bounces up off the ground. So if I refresh once again, it stays in place. All right, now let's continue with this. We're going to be going over how to add in velocities to this. We're going to be going over a few different ways of using velocity. And along with this, since we're done with the actual physics imposter in terms of the alignment and position, I can then make this invisible. So I can set this either to is visible equals false or set the visibility down to 0. Let's go back into our code and let's modify that. Okay, so I'm going to use the visibility. I'm just going to set this down to 0, which will make it invisible. We could also set it to is visible equals false, but since we already have visibility, I'll just use that. Okay, so now let's take a look at how we can adjust the velocity of this mesh. The way we would do this is by modifying the physics imposter, and we're going to be modifying the rocket COL. This is what has the physics imposter, and that is the main parent. So we're going to start off by saying rocket COL dot physics imposter dot, and we're going to look for set linear velocity. So set linear velocity will allow us to basically apply a velocity in any direction that we want, X, Y, or Z. So this takes in a vector 3, and that's pretty much it. Now the vector 3 that we're going to be passing in has a value where we can provide, say, like a force value along that X-axis, Y-axis, or Z-axis. So what I mean by that is, let's go and start typing this out. So I'm going to write out a new vector 3 in here. And let's say I want to apply a force along the X-axis. I'll type in a 1 for that, or I can also type in 10, 100, whatever that may be. So that could be the force value along that specific axis. I want this to go straight up. So we're going to say 0 for the X-axis. And let's start off with a value of, let's go with 1 along the Y-axis, and then 0 along the Z-axis. Okay, we'll just save this as is, and we'll take a look at our scene. Okay, so it looks like it's bouncing just a little bit, and that's because the velocity is not that strong. So with a velocity of 1, this barely moves it up. Let's go back into our code, and let's bump this up to a value of 10. Okay, going back to our code in the velocity, let's bump up this value to 10, and let's see how much of a difference this makes. Okay, and there we go. We can see it pop up, and then it comes back down. Now, that works kind of well. You can see it does actually move it up, but we want this to actually fly and stay consistently flying up into the sky. So the way that we would do this is by modifying that value over every frame. We can use different types of functionality for this, but we need something that allows us to iterate that over and over again and apply small changes to the velocity over time. So let's take a look at how we can modify that next. Okay, going back to our code, I want to do the same thing as before, but I want to do this over every frame. And we're going to apply a smaller value over that frame. So let's bring that back down to 1. And we're going to use something that we've used before. So this dot scene dot, and we're going to say register before render. Remember, this allows us to register a function to be called every frame. So in my case, I don't have a separate function for this. Let's go and create a separate function for this. That way we can register this and then unregister it when we're done. I'll create this above before we create the register before render. That way we have access to it and we can call it as needed. So we're going to create a new variable here called rocket physics. This will be an arrow function. Then we're going to take this guy in here, cut it, and put it in there. Okay, so now I'm going to be registering this function inside of here. We're going to call rocket physics in there. Okay, now the way this is going to work is that every frame, remember a frame happens multiple times per second. So if we're thinking about 60 frames per second, we're then going to be calling this 60 times per second. So every 60 times, we're going to be calling this. So think of this as applying 60 along the y-axis every second. So by keeping this low, we get a nice consistent slow rate of velocity up into the sky. So let's save that and let's take a look at what we have so far. Okay, there it is. You can see it flying into the sky and it's a nice, consistent, smooth value. Okay, so right now we have it flying straight up into the air, and that's fine. Let's add some rotation to this as well. So I want to slowly rotate it as it's flying in the air. Okay, going back into our code, now we're going to be using angular velocity. And the angular velocity is going to be nearly identical to how we set this up with the linear velocity. So I'm going to copy that, paste it below, and replace linear with angular. Okay, with angular velocity, we also provide a vector 3, but this basically allows us to determine the rotation. So the rotation force of that rocket. We're using the y-axis once again. That's going to be up and down. So it's going to be rotating up into the sky, and we're also applying the linear velocity. So it's going to fly up, and it's also going to be rotating while it's doing that. Again, just like before with the linear velocity, a value here will determine how much force is being applied for the angular velocity. So if you want this to spin quite fast, you can up the value that you're using for that axis. All right, let's go and save this and let's take a look at this now. Okay, there we go. Now we can see that it's rotating and it's rotating along the y-axis of the rocket, flying up into the sky. Okay, one other thing that I want to add in is the ability for the camera to follow the Y position of the rocket. So as it's flying upward, I also want the camera to fly upward with it. Let's modify our code to adjust the position of the Y axis of the camera. Okay, going back to our code, I want to modify the position along the Y axis of the camera to match the Y position of the rocket COL. In order for me to access the camera in this method, I need to create a new variable at the very top. So camera, this would be free camera. Then down below where we created the camera, so in our create scene, we have it right here. I'm just going to say this.camera equals camera. That way we have access to it. And then down here in the rocket physics, I want to make sure that I update the position of the y-axis of the camera every frame to match the position of the rocket COL. If you do this outside of this, what's going to happen is it's going to do it once, and that's all it's going to do. So it's never going to catch up to the rocket. So I'm going to say camera, actually this.camera.position .y equals rocket COL.position .y. Okay, so every frame this gets called, we're updating the Y position of the camera to match the Y position of the rocket. Let's save this. Okay, there we go. We can see that our camera is following the Y position of the rocket. This can be a very easy way to have objects follow each other. So you can set the position of one object to match the position of another object. All right, let's take a look at one other thing, which is to left click on our scene. And when I left click on my scene, I then want to have the rocket stop flying up and stop any kind of velocity that's being applied to it. So this could be used if you wanted to, say, have a game over state in your scene. Let's say we reach the end of our game and then the rocket is going to fall, or maybe we hit something and it's game over. In either scenario, I want to unregister the velocity that's being applied to the rocket. And for that, I'm just going to be using the left click on the scene here to determine if we're in a game over state. So let's take a look at how we can set that up in our code. Okay, so before we start writing out some code, let's kind of discuss how we would approach this. So right now we're registering a function called rocket physics. And this happens before we render. This happens multiple times per second. We're going to be calling this multiple times per second. And I want to unregister this. But how would I determine when I want to unregister this? Well, I want to do this based on when I left click on the scene. This is a very simple example of how we could set this up. You may want to have additional logic in your game, whatever that may be, for a game over state. So let's say we enter a certain trigger zone, maybe we hit an object that we're not supposed to, and then it's game over. In my case, I'm manually triggering that with a left click on the scene. So for that, we're going to be using something called this.scene.onPointerDown. And with the on pointer down, I can create an arrow function. And I can do the same thing as before, but now I can unregister this. Okay, I'm going to copy this, paste it in here, and just say unregister. So when I left click on the scene, I can then unregister this. But you'll see that if I unregister this after I left click, it's going to automatically call this again because we haven't determined when we could re-register the rocket physics. So it's going to happen automatically. So we need to have some sort of condition to check, hey, can I register the rocket physics again? If not, then don't. So we're going to use a Boolean for this. I'm going to create it right above, right before we create the register before render. So and we're going to call it game over. Okay. And I'll set that to false by default. And now down here, I'm going to say only if game over is false, will I then register the rocket physics for that. And in here, I'm going to set it to true. So whenever I left click, I'm going to be setting this to true. And then I'm also going to be unregistering it. So I'm going to say game over equals true. Okay, see this in action? Okay, so the rocket is flying up. Now, if I left click in here, we should stop the velocity from being applied to this object, or rather we're stopping the function that would allow us to apply velocity to the rocket. Left click in here, and the rocket's gonna go straight down because it's using gravity. We're no longer applying velocity to that object. All right, so once again, if I left click in here, it's automatically gonna stop and fall straight to the ground. Okay, now let's take a look at one last thing, and that's going to be the local axis of this object. So right now we're using the world axis. We're going straight up along the y-axis. But if this rocket were to be rotated at an angle, it would still be flying upward. So let's go ahead and demonstrate how that would work. I'm going to go back into our code, and we're going to modify some things. Okay, going back into our code, let's take a look at modifying the rotation of the rocket COL. I'll do this after we create the set parent. I'll say rocket COL dot, and this time I'll use something called rotate. Rotate takes in an axis. So the axis that I want to use is the z-axis, and a shorthand way of writing that out is saying vector3 dot forward. Okay, so forward is similar to writing out vector3 0 0 1. That is the axis that I want to rotate along. The second value here is the amount or a number. This is in radians. So if I want to rotate this about 45 degrees, give or take, I write out 0.75. Okay, 0.75 radians is roughly about 45 degrees. And then the last value in here is going to be the space. By default, this will be in local space, so I don't even need to provide that. I do want to use the local space, but if you want to use the world space, or let's say you're going from world to local, you would then want to apply a value for that. I do want to use the local space, so I'm going to leave that empty. Okay, and I'm just going to save this as is. Let's take a look at the physics in play with our rocket rotated at a 45-degree angle. Okay, so as you can see, our rocket is rotated, but as you can see, it's not really propelling the rocket from where the afterburner would be on that rocket. I want to have the forces applied along that local axis of the rocket and not rotating or being pushed up in this way. Let's take a look at how we can modify the local axis of this. Okay, going back to our code, if you want to use the local axis of the rocket, we're going to do this with the linear velocity. So I'm going to comment out the angular velocity. We're going to be swapping out this vector 3. So I want to use the rocket COL this time, and I want to use the upward axis, the y-axis of the rocket. So if it's pointing at an angle at 45 degrees like this, I want the rocket to fly in that direction. So let's pass in the rocket COL dot up. Okay, if I hover over this, this is a vector 3. It is the up direction of that transform in world space. Now we are going to have some issues with this, but let's just see if this works as is. Okay, so right away we can see that it starts off at an angle, and because it's pushing it along the y-axis, it then rotates it downward. So let's modify this. We know that this is working with the local axis, but now I want to have the camera follow the rocket along both the x-axis and the y-axis. And let's have this fly towards the side. So I'm going to rotate this completely 90 degrees, and we're going to see it fly towards the x-axis. Okay, now going back to our code, let's take a look at the rotate. This time I want to use a higher value for the rotation along the z-axis. We're going to set this up to 1.5 radians, which is roughly about 90 degrees. Now, along with that, I also want to adjust the camera's position. We're no longer going straight up, we're going at an angle. So I want to adjust the X and the Y position if we did want to modify the rocket along those axis values as well. So instead of saying just Y, I'm going to say the camera's position is going to be equal to a new vector 3. And here we're going to be passing in the y-axis and the x-axis of the rocket. We're going to paste this in twice. The first value is going to be the x-axis of the rocket. I also want to follow the y-axis of the rocket, but the z-axis I want to keep at the same position for the camera. So I'm going to say this dot camera dot position dot z. So wherever it's at along the z-axis, I still want to use that same value. Okay. And then for the up value here, we can also increase we can essentially apply a multiplier to this by saying dot scale, and let's multiply this by 5. So we're going to use a multiplier of 5 along the up axis of the rocket. Okay, let's go and save that. Let's take a look at this again in the scene. Okay, there we go. Now our rocket is rotated at a 90-degree angle. It's flying upward slightly, and you can see that the camera is following it along the x-axis and the y-axis. Okay, now let's take a look at using the up axis for the angular velocity as well, and then we'll finish this up. Okay, going back to our code, let's take a look at the angular axis. We're going to use the same value as before, but I'm just going to use rocketcol.up. I'm not going to be using the scale with this. So this will be a lot slower overall for the angular velocity. We're going to say rocketcol.up, and that's pretty much it. So there you have it. That's how you use velocity within BabylonJS.